All right. Welcome everyone to these next set of notes. Make sure you have your paper and pencil out ready to copy everything down in order for you to fully understand this lesson, right? So here we go. First thing that we do, as always, is we identify the name of these notes, which is circles, chords, and their lengths, right? Circles, chords, and their lengths. So let's hit up the 4 bullet points here, right? So bullet point number 1 says, right, this first I here, it says a special chord is a diameter which equals to 2 radii, right? So 1 diameter is equal to 2 radii. Radii, guys, is plural for radius. So you wouldn't say 2 radiuses, you would say 2 radii. All right. I number 2 here says all radii within a circle are equal to each other. So all radii within a circle are equal to each other. Okay. I number 3 here, intersecting chords create 4 segments, right? So when 2 chords cross each other, it creates 4 segments. And our last bullet point, our last I here, says the products of the segments of each chord are proportional. So these 4 things might not make sense right now, but they will. They will. Okay? But before we get started in the examples, let me cover this last I, this last bullet point here. So if you notice here, we have 2 chords, right? This chord here and this chord there, right? This chord is made up of A and B. This chord is made up of C and D. So where they cross is right here. And if you noticed, when they crossed, that chord crosses with this chord, it created 1, 2, 3, 4 separate segments. A blue segment, a red segment, an orange segment, and a green segment. Now, what bullet point, and that's what I number 3, the third I said here, right? Intersecting chords create 4 segments. 1, 2, 3, 4. Now, this last bullet point says the products of the segments of each chord are proportional. What does that mean? So what that means is, you see this chord right here? This chord is made up of the blue and the red, right? So when I multiply blue times red, or A times B, right? A times B, that is equal to this chord here, which is orange and green. C times D is equal to C times D. It's a terrible D. Right? C times D. A times B is equal to C times B. D. A times B, that's 1 chord, is equal to C times D. That's a 2nd chord. Look at that. Right? So this is what we're going to use for our specific problem. So let's take a look first, though, at some other examples. So the instructions say we're going to find the length of the segment indicated. We're going to round our answers to the nearest tenth if necessary. Okay. So let us take a look here. So we have our circle here, right? And we have our diameter here that goes, that goes from this side of the circle all the way across to that side of the circle. It's a diameter. And we have this radius from the center to the side is 3.9. Right? That means that this radius is also 3.9. Look, from the center to the side of the circle. Technically, so is this one. Center to the side of the circle is 3.9. And this one, center to the side of the circle, is also 3.9. Now you're thinking, mister, is this one for that one also 3.9? Well, no, because look, it stops right here. It doesn't go all the way here. Now, how do we get this x here? Now, if you notice, this 3.9 is equal to this 3.9. That means that this 3 is equal to that x. So this one, kiddos, is simply x is equal to 3. Right? X is equal to 3. So that means because this is 3, then that's equal. They are equal because this 3.9 was equal to that 3.9. Right? So congruent parts. The top was congruent to the top. That means the side was congruent to the sides, right? These chords here inside this circle. So simple enough, right? Let's move on to the next example here. So let us take a look here. So let's find our, well, this is our diameter that goes from one side all the way to the other. Okay, and they're telling us that this radius from here to here is 11.5. That means that from here to here is also 11.5. And from the center to this side is also 11.5. But guess what? From here to down here is also 11.5. So this x and this 5.1 together is equal to 11.5. So this x plus that 5.1 is equal to 11.5. Look at that. So let us solve. Let's move minus 5.1 over. So I get x is equal to 5 minus 1 is 4. 11 minus 5 is 6.4. And there you go. Look at that. Right? So the way I knew that, right, the way we identify that is because 11.5, and this is also 11.5, and that also is 11.5 because those are radius from the side to the center. That means that this one was also 11.5, and this is where I had my x. Look at that. So these two together is equal to these other ones, which they're all 11.5. That's why I did x plus 5.1 equals 11.5. Perfect. Perfect, 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 perfect. All right. So let's take a look here. Let's see. So let us use our cool highlighter here. So that means, okay, I have a radius from the center to the side. That is equal to this radius from the center to the side, which is also equal to that radius, which is the center to the side. So if you notice, this is equal to one of these here, which is half of this whole thing. So half of x from here to here is equal to this also radius from x to there. So that means that 4 plus 7.7 is equal to x half of x. Well, half of x is divided by 2. Right? We take something we divided by 2, we divide it in half. So 4 plus 7.7, right? Let's see, make sure that I got it right here. 4 plus 7.7 is 11.7. All right. 11.7, and I still have x divided by 2 left here. The opposite of dividing by 2 is, the opposite of dividing by 2 is multiplying by 2. So 2 times 11.7, so let us hit enter. The answer, which is 11.7 times 2, 23.4. Look at that. So we get 23.4 is equal to the x. There you go. Look at that. This diameter from this point of the circle to that point of the circle is 23.4. Perfect. Perfect, perfect, perfect. All right, 3 examples down. Last one to go. This is just like that right there. Look at that. 2 chords crossing each other, right? And where do they cross? Where do they touch? They touch actually right here. And they create 4 segments. 1, 2, 3, 4. And those segments are going to multiply. A times B is equal to C times D. So what I'm going to do to help me out is I'm going to name them A, B, C, and D. And I know that my formula says A times B is equal to C times D. A is 2 times B is 36. C is 12. And D is X. All right. 2 times 36 is 72. 12 times X is 12X. The opposite of multiplying by 12 is dividing by 12. 72 divided by 12 is 6, is equal to X. And there you go. Look at that. We have found X, right? And we did it by identifying A, B, C, D. A times B is equal to C times D. Right? And that right there, kiddos, are our notes for this lesson. So make sure that you have everything written down, right? Rewind if you have to make sure that you understood it. But this is the kind of work you're going to see in your next assignment. All right? Thank you guys for being here. See you next time.